welcome to this very brief presentation on content-based video analysis. It's a very specific topic, as you can see, and I listed a subtopic below, which is genre-based video classification. So we will look at content-based video analysis in light of genre-based video classification. Alright, so what is really genre? So it relates to the organization of any digital video library or online library, say like YouTube. We intend to do only a high-level classification, and as you can see in the picture, there's a video clip which can be classified into different genres like movies, sports, or news, or cartoons, or commercials, etc. We're not looking into subgenres like what kind of sport it is or what kind of movie it is. We're just looking at very high-level classification. And as you can expect, the number of categories here or number of clusters is predefined. So, and it can also be added on the fly. But for the initial set of classification, this number of clusters is to be predefined. You can always add any kind of miscellaneous states so that if you have videos which do not fit into a particular cluster, you can always classify it as a miscellaneous video. This slide details a pipeline on video content analysis. So what do we actually mean by video content? There are two parts to it. There is a visual track and an audio track. Now the algorithms surveyed in this paper are concerned only with the visual track. I'm not looking into the audio track. And the pipeline consists of three steps. The first step is pre-processing, and the second step is feature extraction and context modeling. Context modeling is defining a probabilistic model to represent your features, to represent the interaction between the features. And feature extraction can also act as a standalone system for a classification. And if you use a context modeling approach, it will become more generic. And this will become clear in next few slides. Now, why do we need a classification for a digital library? Of course, a classification facilitates easy retrieval. And if you want to do a certain set of tasks on a particular set of videos, then if you have videos classified, then it becomes very easy for you to pick the particular video and perform a set of tasks. Now what is video pre-processing? Now why do we do pre-processing? Because if you have long duration clips, we have large information and a combination of both relevant and non-relevant information. And you want to reduce the information and you want to really keep the necessary content that matters. So we use, as a pre-processing step, we use shot detection algorithms, which detect abrupt or gradual scene changes in a video. So as you can see in the picture, a video can be represented as a collection of shots, where each shot is a collection of frames. And if you look at the picture, the first frame and the last frame are being shown, and they are not much, they do not have very much variations. So it's just a shot is being defined as a set of frames which is captured uninterrupted by a single camera. So we know shot as a particular scene in a movie. So there is not much variation between the frames of a scene. And so this video, any video can be represented by a finite number of shots, and each shot can be represented by a representative set of frames. Now, this subject is about feature extraction. Now, the feature extractor should particularly use the domain knowledge, which is very important, to distinguish between, say, sports or news videos. We can use camera motion dynamics. For example, a sports video typically is a live broadcast, and the camera motion is very high in a sports video. There is a lot of camera noise compared to a news video. News video is just you use a static camera, but in a sports video it might be a static camera or a camera which has a very high dynamic motion because there are a lot of things happening in the sports video. And feature extraction systems can act as a standalone system for classification. So just extract features, put it in a set of classifiers, ask them have a training set, and ask them to label, ask them to classify. So that's a definition of a standalone system. So feature extraction can also act as a standalone system. Classical feature extraction algorithms can be used. For example, any kind of interspon detectors, region-based classification that is being outlined in the next point. So extracted features can be both at frame level and region level. At frame level, you just typically model the dissimilarities or similarities between keyframes. Keyframes are set of frames to use to represent a shot. Now, these similarities or dissimilarities can be based on any kind of indexes. A lot of indexes have been defined in the papers listed below, and there can be also region-level features being extracted, which can be depend on describe the region based on texture, or color or orientation histograms. Now, this is a very recent method of putting context into classification. We use probabilistic models to model context. Now, there is one particular thing shown here, which is a model of Markov model. Now, a temporal sequence of video can be classified into these three states, these three blocks. The first state can be a dialog state, or second state is a progression state, and this is third state, miscellaneous state. And this particular HMM is modeled for a video with a narrative sequence. So any video can be classified into all 3 different kinds of blobs, where the blobs are to be named by the user, to be named by the person who actually tries to classify it. And this essentially enables definition. These are called semantic labels, these blobs. And so what you can do is you can extract the features and put into any of these semantic labels and group them accordingly. Now this particular picture shown here, it's an approach, very popular approach. It's called multi-text. This is like, there are a lot of indicators shown in the clip. So one video frame is being classified, put into different groups, which are essentially semantic labels again. So they are outdoors and sky and snow. So what exactly this frame represents. So this can be extended to model a group of shots and can be extended again to the entire video sequence. Now there are some experimental results being shown here, and this experimental results is only based on a feature classification approach. The context modeling is not being currently used as a classification approach. That is my own idea of extending it. Now this is just a result from a directly extracted feature vector. It consists of 11 features, and this is for classification of short duration clips into 5 different classes: sports, news, cartoon, commercials, and music. As you can see in the table here, the accuracy, the best accuracy being achieved is 90% classification. And if you reduce one of the categories, the minus represents you cut off one of the categories from the entire set of clips. So if you reduce one of the categories, the accuracy naturally increases. And this also kind of tells us about the limitations of a feature extraction approach. So you really cannot find only features which can distinguish between, like you have 10 different clusters. So you have to put context into the picture. How do you put context into the picture? You model the video using a probabilistic method, using a Bayesian network or a hidden Markov model. Okay, so, yeah, and sorry for that. And to conclude, I really want to say, use of context modeling is a more general approach. So we want to define some kind of semantic sublabels for each category. For example, for sports, we have to define a set of semantic labels for which you can extract features and put into them. And we have to relate between different categories. The problem with the definition of semantic label for each category of genre is you really do not know what is the exact sublabels you can define. You can actually relate to a particular category. For example, for a cartoon commercial, you have to think a lot before defining your sublabels. How can you describe a video in terms of all these sublabels? It's about the user. Sorry, it's about the person who wants to classify it. And feature extraction without any kind of context is also very difficult. As you've seen, the accuracy is very limited, and it cannot be really increased when you have a lot of clusters to be classified. And we have to, the one thing that can be used, of course, is audio content, as was discussed in the earlier presentation. This particular survey deals only with the visual track of the video, and the audio content can also be used and combined in an effective way so that it becomes a multimodal approach to classification, and I think it will improve accuracy a lot. Such an attempt has been made, but it is not very successful in the paper listed below. And also user description or popularity can be used, but it should be robust to false alarms and inaccurate tagging. You just cannot take any tags from the user description of a video and allow that to be a description of your video. You have to, your system should be robust to what kind of false alarms or inaccurate tags the user might put, or some kind of arbit descriptions that the user might give to the video. And that's my presentation. It's just a comic about inaccurate tagging in YouTube. The internet has always had loved dumb people, but I've never seen anything quite as bad as people who comment on YouTube videos. So this ineffective description of videos in YouTube by the other users. So says that.
Good, thank you.
That's it.
Thank you.